everybody made it back. Okay, so hopefully this first few are pretty straightforward now. When there's only one term on the bottom is awesome. That's a linear thing. Pretty much just eyeball it and tell. What can x not be here? X can't be 1 because that will make the bottom 0. Here, x can't be, because that will make the bottom 0. Here, you got to be a little careful. A few people got part of the answer, but there's 2 parts to this answer, right? Because it's x squared. How do you factor this?
X plus 4, x minus 4.
So x can't be negative 4 or 4, like that. And then this one, I love how everybody sort of reaches and said, I had to do work here, I must have to do work here, and then you start messing with the top, but I didn't look at the top at all in any of the other problems. The process can't change just because the problem changed a little bit, right? So here, we did one just like this before. Can I make the bottom 0? No. See how x is on every single bottom, so I have control of it. Where the x is, I have control. I have no control here. It's always 7. I don't care what I make x, it's always 7. So no values, make it undefined. However you want to say that, you can use all values of x. No values have to be thrown out. Never undefined. However you want to say that. I like it. Okay. Number 2. Alright, I'm going to do this problem, and then I'm going to show you a semi-shortcut on this problem. The bottom is the easier thing to start with, hopefully. Right, 2 terms, it can only be squares or cubes, it's got no GCF. So how do I factor that squares?
Minus 3, plus 3.
Let me see if you guys can handle that. Did everybody do like 2 times negative 15 up here?
Yes.
Yeah.
Yeah. So negative 30, and then you add to get negative 7, so it's going to be negative 10 and 3, and then you can break up the middle term into 2 parts, minus 10a plus 3a minus 15. Yeah. So just to cut to the chase, you'll get 2a plus 3, and you'll be left with a minus 5. Is that what you guys got for the top there?
Yes.
So then bam, bam, you should get a minus 5 over 2a minus 3. Cool, I like it, right? Now just to show you a slightly different way to go. This might apply to some of the homework too. So that's done. That's the problem. I don't need to know what I'm about to show you to do the problem because we just did it. But notice how the bottom is 2a plus 3, 2a minus 3. So I bet you anything, the top is going to have a 2a and a 3. Right?
Yeah.
So I can use what's done as a hint. So 2a times what is 2a squared? 2a times a. 3 times what is 15? 5. And now I just got to figure out the signs. All right, so either this is negative or this is positive. So I get a 10 and a 3. The 10 has to be negative and the 3 has to be positive. Do you guys see what I'm saying? You have to know how to do this anyway, so it's no problem at all if you never use that shortcut I just showed you. I don't care. You get more practice doing this anyway. But the shortcut actually sometimes comes in real handy. There was a problem somebody was asking about where it's remarkably disgusting to do it this way. And it's easy as all hell to use the clue. Bam! So then you still get a minus 5, 2a minus 3. Bam! A be there. Use a hint or not. All right, let's just keep going here. This guy. And again, some of you guys would very much benefit from breaking this up into the 4 problems it is. Because you're sort of all over the place, and then you're trying to guess at what parts go where, and then you get lost, right? So let me do it that way for this one. I believe this is 1, 2, 3, 4. So I got 4 problems. Number 1, m cubed plus 9m squared. I can just do what?
Factor out on m squared.
Yeah, so GCF. Okay. Now this guy is interesting. It starts off as just
m cubed. Well, m.
Yeah, what can you take out?
An m.
An m. So you're left with m cubed.
Minus 1.
And then this, of course,
Difference of cubes.
yeah. So m, so it'll be m minus 1, m squared, plus m
plus 1.
plus 1. I like it. And then third problem is here. How do I factor this guy? Notice how the 9 is 1 away from the 10, so it's going to be itself and 1. Is that cool?
Mm-hmm.
And then I think I heard somebody saying for the fourth one, take a 3 out, and you're left with m squared plus m plus 1. That sounds very familiar.
Mm-hmm.
So now if I put all that back together, of course doing it this way takes up a little bit of room, but all. If I put all that back together, I'm going to get m squared times m plus 9 over m times m minus 1 times m squared plus m plus 1. That's the second one. Now these, of course, I have to do what? Because it's division.
Flip.
Flip it. So I'm going to put the times 3 m squared plus m plus 1. So that fourth problem we just did, that's going to flip up to the top here. And of course this guy is going to flip on the bottom. He's going to be m plus 9, m plus 1. And now you can just kind of go to town. The m plus 9s go away. This whole m squared plus m plus 1 goes away.
And the m's reduce.
Yeah, exactly. You lose an m here. Right? So then you end up with, there's an m left and a 3, so you end up with 3m over m minus 1,
M plus 1.
m plus 1. And you don't have to re-multiply stuff out. You can just leave it in factored form. There's no point to multiply it out. Gross. So if you need to, you can do this. It will take a little more room, but at least it's a little more organized. If you don't need to, then you can just do it all in one problem. No problem. Okay, cool. So what about, oh, yes?
For the fourth problem, the 3m squared plus 3m plus 3,
Yeah.
you can't divide the 3 out, you have to put the 3 in with the parentheses.
Yeah, there's nowhere for it to go. There's nowhere for it to disappear. I mean, if there was a 3 on top, it could cancel. Otherwise, that 3 can't just go away. You see what I mean? Yeah. If it was equal to 0 or something, then it could divide both sides by 3.
Okay.
But it isn't, and there's no other 3 to kill it. So it's still there. Okay, so what about this part C, dude? This is not too bad. They're both over 12. Yeah, I love that shit. So you get
8 over 12.
8 over 12, and you're like, I don't believe it, and it's fine. And then you reduce that to be
2/3.
2/3. Kick ass. Appreciate that. They already have an LCD, and it's a number L. Holy shit. So you're going to love that. Of course, I immediately followed with this guy. Let me make one that we can see. They have the LCD, but what's the thing to be careful about here?
The minus.
Stupid minus. So you get x plus 5
Minus 3.
minus 3
Plus 2x.
plus 2x. I love it. So you get 3x plus 2 over 6x plus 4. What can you do at the bottom?
Factor out of 2.
Good. Now here's the mistake I get.
It's 1/2.
Yeah, that 2 is supposed to be on the bottom. I like it. So I know there's a 2 left alive, but it's left alive on the bottom. Where'd that 1 come from? It's always here. I love it. It's the correct way to look at it. You can either say that divided by itself is 1, or there's always a 1 just hanging out. So when everything else disappears, it's suddenly, I can show up. Holy shit. You will write me down. 1s are going to go on strike eventually. All right, now this one is a nice example of the problems we were doing earlier, to be honest, because one of these has only one part to it. So I'll bet you anything this has got an x plus 8 in it. X plus 8 times x
Minus 2.
minus 2, so who's missing something?
The right side and x minus 2.
Yeah, this guy is missing an x minus 2. I always hate it when people are able to give this something. He doesn't need anything. He's got more than the other dude. Doesn't need anything. So this guy needs the x minus 2 to be the same. So let me do something differently than what I did before. I would distribute right there. Let me make a point because somebody was asking this question. That's what I have so far, right? Can I cancel those x minus 2's?
No.
Definitely not. Because it's part of an addition problem. Right? You guys see that? So I cannot cancel something out unless it is a factor of the top and the bottom. X plus 2 is not a factor of the top because it's not something times something. It's something plus something. I can't break into that addition problem. And if you really think about it, if I were allowed to kill this, why the hell did I need it in the first place? That doesn't really jive. I need it. And then suddenly on the next step I go, I didn't really need it. There's no way the top is going to be 7. You guys agree with me? There's no way it's going to be 7 because this guy needs something. It's not going to suddenly disappear. It doesn't make any sense. So now I do distribute. 5x minus 10 plus 2 is 5x. Minus 8. And so nothing, the top won't even factor, so there's no chance for it to go any further. And I appreciate, sometimes my bonus problems are hard and gross. At least half the time my bonus problems are easy. The bonus is just realizing something. So this, you should not have dealt with any LCDs. There's no point to that. It's sort of like related to if I ask you to do, what is 16 over 4 minus 25 over 5? Do I get an LCD? No, what's 16 divided by 4? Or what's 25 divided by 5?
5.
4 minus 5, negative 1, yay. I mean, so if I can reduce them, then yeah. So sure enough, here, this is x minus 5. Got it. X plus 4. So the x minus 5's go away. This is 4 times x plus 3. The x plus 3's go away. This is x times x minus 7. The x minus 7's go away. So I end up with x plus 4 minus 4 plus x.
2x.
Yeah, so that's 2x. Bam. Good job. So quite a few people get that, but also saw quite a few people with a lot of shit like, whoa. And again, it was a bonus problem. I mean, that's the thing to realize is you can still reduce it, and maybe it's easier if you do. Okay. So any questions from that sheet? That covers 7.1 through 7.4. We're going to do a little out of 7.5, and then I'm going to let us out, right? We just happen to be leaving early every day, which is nice. Again, don't think it's going to be that way forever. But we'll probably do that a few more times at least. Put you here. There you go. Now what's going to be about 7.5 is we've actually, when I explained to you why you multiply by the reciprocal when you divide fractions, we actually did a problem like 7.5. So 7.5 is the fracception section. It's got fractions inside of fractions, right? It's like a Russian nesting doll. Another fraction, sure. Russian nesting doll? No? Those are cool. Russian nesting doll. Another doll, another doll. Okay. And another one. And another one. Oh yeah, shit. I don't know if you saw this. Let me put it up here again. Quiz Monday, Appendix D through Section 7.2. What's happening next Wednesday? Test. Holy shit. So on Monday I'll have maybe tomorrow if I think about it, I'll have the practice test. And then on Tuesday I'll have the answer key for the practice test. Yeah.
How does the quiz grading go and the test grading go? Is that on the
slowly?
You gave us?
Oh. What's? I'm sorry?
The grading on it, when do we kind of see that? Do we see it before the test, like the quiz grading?
I'm going to give you these tomorrow.
Oh, okay.
Yeah, I pretty much always give you the next day.
Good enough.
Yeah.
Thank you.
I always hated it. I had a class where we didn't get anything till the last day of the semester. He had a big box of all our stuff, and I was like, I hate you. So, still fresh enough in my mind that I tried to give you everything back the next day.
Cool.
Yeah. Okay, so here's how these look to begin with, and then we got to look at a couple of worse ones. So you guys remember, sort of looks like the example we did. Whoop. Sure. So the thing to realize is this is just 8/9 divided by 4/5. How do you divide fractions?
Multiply the reciprocal.
Multiply by their simple. So you get 8/9 times
5/4.
5/4. And then of course,
Reduce.
yeah, before you multiply, I want to see if stuff reduces, so you got smaller numbers to work with. 4 goes into 8 twice.
10/9.
10/9, is that decent, you guys?
It's just a different way to write it, right? Essentially.
Exactly. Yeah, so this is a different way to write 8/9 divided by 4/5. Now, is every problem going to be like that? No. But that's where they start, with this idea. I like it. So where are they going to go from there? Well, I mean, the immediate next level would be something like this. Sure. Now, I want you to realize something about this problem. Let's see. 3 over n plus 1 over 6 over n plus 1.
Those just cancel out, won't they?
Yes. Yes. So hopefully you guys realize the top and the bottom both have over n plus 1. So they're just going to cancel. Is that cool? Or if you multiply by the reciprocal, the first thing that's going to happen, the n plus 1 is going to cancel, right? So you can actually right now just go, well, these cancel. And then 3 over 6 is done. In fact, tell me, 3 n plus 1s, how is it related to 6 n plus 1s? It is half of that. That's what the answer really means. Okay, maybe. Now, if you don't see what I just did, you can always do like we did the first problem. 3 over n plus 1 times the reciprocal. Those cancel. 3 over 6 is 1/2. So that's just a little more writing and you get the same answer, so who cares? It's the same thing. I like it. All right, so these are basically the same problem. This one, they just threw some variables in there, but they work the same way as them. So cancel the same way. I like it. So what is going to be different? I'm going to start giving you, cool. Nah, blah, blah, blah. Yeah, let's try this one. This looks nice and gross.